This is the second video on exceptions to the octet rule. This one will be on what is called an expanded octet, and you may recall that there are three exceptions to the octet rule. The first is when you have an odd number of electrons. The second is when you have less than an octet of valence electrons. And the third is when you have more than an octet of valence electrons. And in this video, as you can probably tell from the title of the video, we're going to concentrate on the latter. When you have the expanded octet, the NASB table will not make sense. Frequently, it will be obvious that you have to have more than 4 bonds, and if you have more than 4 bonds, then by definition you have to have an expanded octet. So let's take a look at iodine pentafluoride, or IF5. Well, if you take a look at IF5, it's pretty obvious that the iodine will be the central atom, and now you have 5 fluorines to attach to the iodine, which means you have to have 5 single bonds at least. Each single bond has 2 electrons, so that's a minimum of 10 electrons in the valence shell for iodine. That's an expanded octet. We're going to tackle the problem the same way, but we will notice some differences. So using the IF5 as an example, we're going to start with the NASB table. So we set it up. We have one iodine, which needs 8 valence electrons, and it has 7 available. We have 5 fluorines. 5 times 8 is 40, so we need 40 valence electrons. Each has 7. 5 times 7 is 35. When you add up the first column, it's 48. The second is 42, which means you have to share 6 electrons, which means that there are 3 bonds. But we've already said we know we need 5 bonds, so the NASB table doesn't make sense. We're going to pick the central atom. The iodine is less electronegative than the fluorine. It's also a singleton, so it's the central atom. Now we're going to put the atoms out. We start with the central atom surrounded by 4 of the fluorine, the normal 4 quadrants. But there's still one fluorine left, so we put that in between. Now we're going to draw a single bond between all the outer and inner elements. That's 5 lines. 5 times 2 is 10. So we still have 32 electrons available. So now we're going to add the remaining electrons around the outer elements. And we do that. We see that we use up 30 electrons, but there are still 2 left. So now we're going to add a subrule. Any extra electrons go around the central atom as a pair, and so they go there. If needed, if we think there's more than one possible structure, use the formal charge. There really isn't here, so this is the correct Lewis diagram for iodine pentafluoride. Notice the iodine has 12 valence electrons. Now there are a couple of things to note here. As I said, you may need to use a formal charge to pick the correct structure. It turns out fluorine will never have more than 1 bond, and the reason for that is the element that is going to have the expanded octet must be in period 3 or higher to have an expanded octet. Fluorine is in period 2, so it cannot. So I want you to do the Lewis diagram for sulfur hexafluoride. Go. And this is the correct structure. Let's walk through it. We're going to follow the rules. We'll start with the NASB table. And we've got 1 sulfur, which needs 8, but it has 6 available. 6 fluorines. 6 times 8 is 48. But it each has 7, so that's 42. So that's 56 are needed. We have 48. So we're going to share 8, and we're going to have 4 bonds, and that makes no sense because we know we need to have 6 bonds. Sulfur will be the central atom. We put in 4 of the fluorines in the quadrants. We have 2 fluorines left, so we'll put them, say, here and here. And then use the single bond to attach them all. 6 bonds, have 12 left, so there are 36 left to place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. We've used them all up. Nothing else left. So this is the correct drawing. So to review, there are three exceptions to the octet rule: an odd number of valence electrons, fewer than an octet, or more than an octet. If you have more than an octet of valence electrons, the central atom must be from the third period or higher. The NASB table will not make sense. Only the central atom will break the rule. All extra electrons go around the central atom. And if you happen to have more than one possible structure, use the formal charge to pick the correct structure. And that is how you draw Lewis structures. In the upcoming videos, we'll start to discuss molecular geometry.